Hello guys, welcome to my second video in my C++ series. In the last video we covered how to get set up for programming and what programs to install, so if you're needing that, please check out the video before watching this one. In this video we're going to be going over the basic data types, as well as outputting text to a user and taking input, and what libraries are and what we actually use them for. So starting at the top, you'll see in green text, and this is known as a comment. So right here there's /Matthew and /student ID. This is a comment, and comments are not interpreted by the compiler. So these are just here in case you have somebody else looking at your code, like a professor or a coworker, and you need to get a message across or explain something. Comments are great for that, and that's what we use them for. And if you're a student, it's always good practice to put your name and student ID at the top as a comment. That way, you'll get proper credit for what you do, and it's not going to stop anyone from stealing it, but you do at least get credit for it. And then going from there, if you look below that, we have this #include iostream and string, and these are libraries. And what libraries are, they let us use code that somebody else has already made. It's kind of ready-made code in our program without having to copy it or reinvent the wheel. And specifically here we have iostream, and it lets us output text to the screen and get input from the user, and that's what we're going to be using mainly in this video. And then we also have #include string, and this is the string data type, which we will get to in just a little bit. And this is going to let us kind of display a string of characters to the screen, and this is useful if you want to display words or phrases or tell them what their name is, so on and so forth. And below this is using namespace standard, and we're going to skip this for now. We'll come back to it and explain what this is and why I have this here. Below this is the int main function. And now this is the main function of a program. You always need to have it. Even if you don't use it, you need to have a main function in your program, or it just won't compile, it won't run. So what this is the main way for the computer to get information to the compiler to understand what's going on and for your program to actually function and do what's intended. So we'll dig into what functions are later on. There are going to be a video all in themselves because they are very important and very useful, but it does take some understanding of the basics before we can fully utilize them. The computer is saying, hey, run main. So all of your code that's in there will run. Okay, so now on to the data types themselves. There are many data types, but we're only going to be using a few in this video, and we're only going to be using a few really in all of our videos because some of the ones, while they are useful, while they have their purposes, they're not going to be used every day. They're not going to be used in 90% of use cases because they have very specific uses and very specific needs in order to actually be used properly without wasting space. Quick background on data types. All data types have a certain size, and that is the amount of space they take up in memory, which is your RAM memory. And while it might not be super important to completely utilize the smallest data types absolutely necessary in small programs, when you get to larger applications, every little byte is going to start counting. So while it's not super important to make sure you're using the right thing from the start, it is good practice to just try to get that habit started and created. So while we aren't going to dig into exactly the size of each data type in this video, as it's not completely necessary, we will explore that later on once we have a better understanding of how memory is used in a program. So that's going to be a different video just because it does take a little bit deeper of an understanding, and that's going to be the same with a lot of concepts in C++. You can't really go to one or explain one fully before you get the basics of the first thing down, and that's building blocks. The first data type, the one that is very common, is the integer, and that just looks like this. It's an int, and then you're going to be your variable name, so we can put my number. And so what this is saying that you are declaring, you're telling the compiler that you want to use an integer, and that integer is going to be called my number. So if you want to set my number equal to something, you would just type my number =, and then the number that you want to use. So then in this case, we'll use 12. Bear in mind that at the end of every line in C++, every line of actual code like this using namespace standard, and at the end of integer my number and my number equals 12, we have a semicolon. And that's known as a delimiter, and that is just telling the compiler that you're done with that line of code. Stop compiling and just move on to the next line. If you have one of those missing, you could spend a long time figuring out what's wrong with your program, and really you're just missing a semicolon. Luckily, as this red line pops up, most IDEs are pretty good at picking up this issue, and it'll even tell you it expected a semicolon. Sometimes you won't even know. It'll say it expected a semicolon, but you don't even know in what line it's referring to. So just always make sure you have that, and you'll save yourself some headaches. But that is a lot easier said than done. All right. As far as integers go, they are a small data type, not the smallest, but pretty close, to hold a number. And the size that an integer can hold is a negative 2,147,483,648 to the positive of that number. So if any of you have played the game RuneScape, you will know that this number is max cash. It's the maximum amount of coins that you can keep in one place, and that's because this is the type of data type that they use to represent storing coins and different items in the game. So what they could do is use something like a long integer, which we won't get into this video, or a double, which we will get into this video, and that is just a much bigger data type for storing numbers, and it's double the size of an integer. So if an integer can hold 2 billion integer numbers, a double can hold up to 15 places of a number. So it's very big. It also can represent decimal points where integers can't. Integers can only store and display whole numbers, where a double can display decimal points. But because of the size, because it is double the size of an integer, it takes up twice the amount of space. If you want to just display a small decimal point, you're not going to use a double. You're going to use a float data type. And because I didn't type it in, here is a double. That is how you display it. And it's going to be the same for all of these data types. You're just going to write the type of data that it is, and then the name of the variable. You can name this anything you want. You can have multiple in the same line by putting a comma and then the next variable name. So you could have 3, 4, so on and so forth. So right now we have 3 floats, my float, x, and y. What a float does is it's going to allow you to display a decimal point. So if you are doing a calculator, you're doing calculations, it really is important that you have a decimal place. A float's going to be your better option, more so than an integer, because an integer is going to just not care at all about the decimal places and just chop them off and give you the whole number. And if you're just rounding, that's going to be fine, but if the decimal places are useful or needed, you're going to have to use a float. As far as numbers go, these are going to be your main data types, but if you want to display something like a character to the screen, you'll use character, which is char, or however you want to pronounce it, and then the variable name. And this is going to display a character to the screen, which is like A, B, C, so on and so forth. That's it. If you type in a word, it's not going to store it. So if we say my char is equal to, and put in single quotes, A, then it is going to be equal to A. If you say my char, actually let's have a second one, and we'll call it my char 2, which isn't, great. It's going to be a little confusing if you have a ton of these, but since it's a small program, it's going to be okay. If you have my char 2 equal to, and we'll have a word, you're going to get an issue. This red line is going to tell you you have too many characters, and a char is not going to be able to hold it. And if you try to put a string to it, you're going to have an issue as well. So here, the value type of constant character cannot be assigned to an entity of type char. So because this doesn't work, we can just comment this out, and then we'll get rid of that error because it's not actually being interpreted as a code anymore. So if we want to move on, we can get to string, which is going to let us actually store something like Matthew, or a string of characters. So to do that, just do string, and then the name of your string, and then you can set that string equal to a name. So in this case, we're going to just do name. But this is a way that you can just kind of equalize string to something basic, something default, and then change it later on. If you want to actually start using these data types, we can create a small program to do just that. So in order to get output to the screen, you're going to type in cout, and then your two angle brackets facing out from the program. That's a good way to remember it. If you want to do output, arrows pointing out. If it's input, arrows pointing in. So in order to display a string of text to the screen, you're going to put double quotes and then what you want to say. So hello, and then a common one is hello world, but in this case we're going to do hello, please enter a number. And then to end the output, we're going to do two more angle brackets and then end L with a semicolon. And that's going to display hello, please enter a number, and then now we have to get input. So to get input, you're going to type cin, and then two brackets facing into the program, and then you're going to pick the variable that's going to store the number. So let's do my number. So this is getting input from the user, storing it in as my number, and then now my number is going to be whatever the user enters. It's no longer going to be the number we gave it, because every time you assign a value to a variable, it's going to get an override, and so the newest number or newest character string is going to take its place. So now that we have that, we can do cout, and then please enter your name. Well, before that, let's just kind of show what the string, my string, is before they change it. So my string is, and then in order to display just the contents of a data type or a variable, you can just type in that variable's name. Oops. So my string, and then end your line. So it's going to show you what my string is before you change the contents of it, and then after. So let's do cin. Let's actually get the name, and then cout. My string is now, let's actually display it. So there you go. So our program from here is going to go hello, please enter your number, get the number, display what's in string, get a new name for the string, and then display that new name. But it's not going to display what the number is, so we have to get that too. So cout, this is your number. And there you go. So that should run just like this. It's going to go from here down, and we'll see that in just a second. So if we go ahead and click Local Windows Debugger, a console window is going to pop up in just a moment. All right, there we go. So please enter a number. Let's do 12. Actually, since 12 is what we have, just to prove a point, let's do 20. Okay, my string is currently set to name, and we can see that right here. My string is currently set to name, but let's change that. So let's set it to Matthew. All right, there you go. My string is now Matthew, and the number that we entered is 20. So as you can see, the variable my number was overridden to 20, and my string was also overridden to Matthew. So it's no longer name, it's no longer Matthew. So if we continue to display it, it would never come back to name in our current program. So in order to show what the different data types are, specifically float and character, let's comment this out. Let's practice what's known as a multi-line comment. So what you're going to do is do a slash and an asterisk. And then as you can see, Visual Studio kind of gives you the other one already, so we can just backspace that, and then come down here and just do the reverse of that. So it's going to be asterisk backspace, or backslash, forward slash, whichever one it is. Alright, so now if you try to run your program, it's not going to actually do anything because all of this is just commented out, and just to show you, it's going to pop up, and nothing's going to happen. It's just going to be at the end. So press any key to close this window. Alright, so now we do cout. Please enter a floating point number. This is like a floating decimal point. It's kind of what float stands for. So let's do endl, and then cn my float. Cout. Here is your float. Remember, we can do the angle brackets again, and then just type in my float to display it. And then one way that you can also end a line, which is easier if you're ending already with quotation marks, is to have a /n, and that just says new line. So as long as you put the semicolon there, endl and n are going to do essentially the same thing, and we'll see that in just a second. So when we run our program now, it's going to ask us for a floating point number. So let's do 1.001, and then there it is, 1.001. Let's now get a character from the user. Cn, and let's do my char. And now we're going to get the character, and I'm going to be able to display it. So let's actually bring this back. Let's cut this and paste it down here. Now we have a float, we have a character, we have an integer. So let's take it and display all of it to the screen so we can see what each data type is useful for and what it does. Let's try to put a decimal place in as the integer. You can see that it kind of gets chopped off. So here, if we would enter a number like a decimal place, it's actually going to make the program freak out a little bit. And you can see if I hit enter, it's a pretty bad issue. That's a bug in the program. So we'd have to put something in to stop a user from entering something that's not an integer, and we can get into that later on when we get into functions. But for now, let's see what happens if we continue to run this program. Float is that, please enter a letter. There you go. My string is now 0.001. So what happened was, integer took the actual integer in, and then kind of pushed the 001 onto the next variable. So it didn't even let us, normally just kind of truncates this, but it actually pushed it onto my string, which is very interesting to see how integer actually works. So if we run this again, and actually do what we're supposed to do, and enter in a number, it's going to let us put in a string. So let's put in Matthew again. So now we're going to enter a floating point number. Let's do our favorite. And it's going to display the floating point number. Please enter a letter. There you go. My string is now what it should be. The number that we entered is 2. And as you can see, it displayed everything that we told it to without any issues. And that's because we used every data type properly and as they should be used. And there's some pretty interesting things you can do, even more so than just pushing numbers onto a string, which we can get into later in a separate video when we get into functions and how they work, and kind of abusing data types and making them do a little bit more than what they do natively. Alright guys, that's all for this one. Hopefully you learned a lot about data types and variables. Please don't forget to subscribe and hit that bell icon so you'll be notified when I upload my next video. Until then, I hope you have a good one.